This is going to be a new series about the programming language Java. I won't cover things like GUI or networking, only the basics of the language. If you want to learn more, you can find a lot of good tutorials online. For those of you who are already familiar with Java or programming languages in general, this whole thing will get pretty boring after a while. But if you watch the videos anyway, please let me know if you find any mistake, so I can correct the video to prevent others from adapting my error. Concerning programming languages, you have, just like in other languages, grammar and vocabulary. There's always a set of commands which can be combined following basic rules. To learn such a language, the most important part is to practice it. You don't learn any language by reading a book or watching a video. You have to speak it and listen to other people using it. If you honestly want to learn something from the following videos, you have to take some time to try it yourself. When people learn a programming language for the first time, I often see them run into a wall. They write their first programs like they would talk to other people, as if the program they write is a manual for another human, just written in a weird language. The problem is that they don't know how their computer works, how the computer interprets what they write. That's why we start by having a look in the functions of a normal computer. Imagine a man sitting on a desk in a small room. On the walls of the room there are boxes with numbers on them. And inside each of those boxes there's a piece of paper with another number on it. On the desk, the man has some paper and a pencil to make notes and a very simple calculator. Now we want this man to solve an equation for us. The problem is that man doesn't know anything about math. He can read numbers and write them, but he doesn't know what they mean and how they interact. We can't just give him our equation and expect him to solve it. We have to break it down into simple instructions which he can understand. An example: get the paper out of box 1. Write down the number you see on the paper. Bring the paper back and take the paper from box 2. Enter the number you just wrote down and the one from the new paper into the calculator and press the button called Add. Cross out the number on the paper from box 2 and write the number you see on the display onto it. Put the paper back into box 2. This man now has successfully added the two numbers from box 1 and 2 without actually knowing what they mean or how to do it. Just like our computer. He has no idea what the numbers and symbols mean, but as long as we tell him what to do, he doesn't need to understand them to perform the calculations. Your computer cannot think. He can't interpret what you want. When you click on this video, your computer doesn't know that he should pause it. But he has a set of instructions to follow, which in the end lead to the paused video. Now, breaking everything down to the most simple instructions is a very time-consuming procedure. And if you make one little mistake somewhere, the computer can't correct it for you. That's why we have a program which creates them for us, a compiler. When we write a Java program, we basically just write a description of what we want to happen. And the compiler translates that into a set of instructions the computer can understand. When we write a plus b in our program, the compiler will just create instructions like the one from our example. The compiler is just a program, so we have to follow very strict rules. But you have to admit it is easier to just tell him to add two numbers instead of explaining him how addition works. Now, finally, let's talk about Java. Java is a so-called object-oriented language. That means it has a specific type of structure besides the pure instructions for your PC. You need to understand this structure to write programs, just like you need to know which combination of which instructions will do what you want. Remember the poor guy on his desk from our example in his small room? Imagine there are more rooms next to it, each filled with boxes on the wall and someone sitting on a desk. Now imagine that all those rooms are connected via one big floor. In this floor there are also boxes with numbers on and paper in them. Each person can leave its room and use the boxes on the floor, but they can't go into another man's room, only in and out their own. What they can do is go to another room and give the person inside a paper with numbers on it. Also, each person has additionally to the paper and calculator on his desk a list of instructions. Every person can only follow those instructions. They will never be able to do something else. But since each of them has a different list, we still can do everything we want. You want to add something? Go to room A. You want to subtract? Go to room B. Simple as that. This whole floor with all its rooms and all the people in them is what we call an object. It contains data, informations, in our case in form of numbers written on the paper you can find in the different boxes. It also contains instructions in form of a list of tasks on every man's desk. Each of the rooms represents a so-called method, or some might prefer the term function. The blueprint for such a complete floor is called class. It describes how many rooms we need, how many boxes are mounted on the walls, and also which instructions are written down on the lists in each single room. So, we have classes, blueprints, which tell us how to build objects, which are floors with several boxes and methods, where methods are small rooms, each with a single man sitting on a desk. And a building, maybe a skyscraper with hundreds of floors and thousands of people, maybe just a small hut with only one room, is the actual program. Pooh! You got that? Maybe you want to get that into your head first? Okay, let's make a break here and continue next time with our first real program. Thanks for watching and see you next time.